AB Calculus AB, Unit 8, review for the corrective to get ready for the retest. So I thought I'd try and share these answers. So you can check them real quick if you want. Pause the video if you need to. So let's see. There are the top half of the problems for all 4 pages. I'm going to scoot it up. It's the bottom half for all 4 pages. Okay. So let's try these out. Talk about how the test went. Look at your own test. Learn from your mistakes. And, even some of these I'll probably do different than I have my solutions. I just don't want to redo my solutions, so I'm not going to. But true, false, I need work to satisfy it. So one of the things that we've said is the antiderivative of f is like capital F. So you can say, okay, well, the antiderivative is capital F, A to C, capital F, B to A, capital F, C to B. So you get f of C minus f of A equals f of A minus f of B minus, now you got to be careful, you should put parentheses around this, f of B minus f of C, because a lot of people made a mistake with something like that on test. They didn't distribute this. Subtraction. So if we do that, we get f of C minus f of A equals f of A minus 2 f of B plus f of C. So, I mean, this isn't the same. So we're going to go with false. We can't connect these together because it's subtraction. If it was addition, you could connect them together and they still wouldn't be true. But, maybe some other scenario, changing the minus to a plus by flipping the limits, might work. This would be plus C to B of f of x dx, but then you still can't hook these up. Or, the C should be on the top and the B on the bottom then. Okay, next one. This is the derivative. So the antiderivative of that is f. Integrals undo derivatives. You still got to plug limits in. So we get f of A minus f of B plus f of B. Those cancel out. You get f of A equals f of A. True. So you got to show work. True, false. Okay. Now we just got integration problems. Now these are not necessarily U substitution. I would rewrite this one as x squared minus 6x to the negative 1/2. And then integrate it x to the third over 3 minus 6x. You bump it up 1 and divide by the new exponent plus c. The 6 is in the numerator. 6 was always in the numerator. So it's going to be x cubed over 3 minus 12. We could change it back to a square root just to make it nice if you want. I don't think I want negative exponents for any of the answers. Okay, next one. Now this one I'm going to want to distribute, but before I do that, I'm going to change it to 6x to the negative 1/3. And that's x to the first. So I'm going to distribute this in here, rules of exponents. So we're going to get 6 times 72x to the positive 2/3 minus 12x to the negative 1/3. And then we're going to integrate. So we're going to add 1, x to the 5/3, divide by the new exponent, multiply by the reciprocal, minus 12 x to the 2/3, add 1, divide by the new exponent, or multiply by the reciprocal, plus c, should show up in your work. This doesn't look like it's going to get any simpler. It's 210, 216 over 5, x to the 5/3 minus 18, x to the 2/3 plus c. Okay. Next one, we're going to, I might rewrite this, e to the x plus, you might separate it 1/3 times 1 over x. You don't have to, but there's some issues. Then if you leave the 3 in here and you integrate it with the 3 inside, then you got to worry about the chain rule, like U substitution stuff. Cosine, norm of cosine is secant squared, which is actually one of our memorized derivatives. So it's going to be e to the x plus 1/3 natural log of the absolute value of x minus, what do you take a derivative of to get secant squared? Tangent, right? Tangent. So that can be your final answer. The other way of doing it is to consider the 3 inside, and then you say, okay, well, it's a natural log of 3x, but chain rule says you need an extra 3 in front, so we need a 1/3 in front. And so this is an acceptable answer also, but you got to remember the 1/3. And these are the same because rules of exponent allow you to split this up: 1/3 natural log of 3 plus 1/3 natural log of x. And then this gets kind of wrapped in with the c value. So it is the same. The c value would be different on this one to make up for it. Okay, this one, I've given you a second derivative and a line that's tangent to the curve at this point. So the tangent line is going to give you a couple of things, like it's going to give you the slope at a point and also the y value at the point, because we know the tangent line to a curve, they share a point and they share the slope. So first thing we need to do is work backwards. We've got to find the first derivative by integrating the second derivative. And so we're going to integrate cosine x. And so we're going to get sine x, positive sine x plus c. So we want to find the c value right now. So we want to find, well, f prime at pi over 2 equals sine of pi over 2 plus c. Sine of pi over 2 is 1 plus c, and then the slope should match that. So f prime at pi over 2 should be -1. That's the slope of that line. You can take derivative of this if you want to find it, but it's -1. So that's going to give you a c value of -2. So then we're going to rewrite f prime of x equals sine of x minus 2. So we're halfway done. So we got to do it again. F of x is the integral of f prime of x. So that's the integral of sine x minus 2 dx. So that's going to be negative cosine x minus 2x plus c. This is a different c value. Minus cosine x is the antiderivative of sine, because the derivative of cosine would be negative sine. We don't want negative, so you need an extra negative. So if we plug pi over 2 in, well, if you plug pi over 2 in here, you get negative cosine of pi over 2 minus 2 times pi over 2 plus c. Cosine pi over 2 is 0, so we get negative pi plus c. Now, f of pi over 2, if you plug in here, is negative pi over 2 plus 2. So now we're going to solve for c, and we get c equals pi over 2 plus 2. So we're going to rewrite our final answer. F of x equals negative cosine x minus 2x plus pi over 2 plus 2. That's how you do it. Take the slope and then plug the point in. You got a point. Those are your initial conditions to help you find the c values along the way. Now, most of this part one test was integration by U substitution, which means you should probably try that. If you're not doing it, it's probably a bad idea at this point. So whatever's inside is usually good U. Sometimes we have to do some creative things. 3x squared dx. Now, we want the x squared and the dx. I don't want the 3, so I'm going to divide by 3. So I'm going to rewrite this 1/3. The x squared and dx are now just du, and it's going to be u cubed du. So we're going to integrate that, bump it up 1, divide by the new exponent, plus c. And then rewrite it back in terms of x. Some of you guys left u's in your answers, and I just had to take off points. Okay, next one. U equals 2x, du equals 2 dx. I don't want the 2. So if I rewrite this, it's 1/2 sine u du. Now the antiderivative of sine is negative cosine. We want to write it back in terms of the original variable, 2x for the u. All right. So I got a bunch, there's a bunch of good practice on here. Now, there's a couple options on this one. And after you've done enough of these, you'll start to see this come in the future. We could do U substitution. U equals 2x, du equals 2 dx. Don't want the 2, so then we rewrite it 1/2 sine of u over the square root of cosine of u du. Now, you still can't integrate that, so you got to do U substitution again. We could have done it in one step. I'll show you in a second. So I'm going to call this v because we can't just call it u. I'm going to call it v equals cosine u. So dv equals negative sine u du. Perfect. I don't want the negative though. So I rewrite this. It's now negative 1/2 dv over the square root of v, which is v to the negative 1/2, which is v to the positive 1/2 divided by the new exponent plus c. But then we got to rewrite v back into u, so that's going to be cosine of u to the 1/2. But then you got to change it all the way back to x, so it's negative square root of cosine of 2x plus c. So that's one way you could do this problem. The other ways you could maybe see this coming, or even if you realize it right here, just start over and just be like, all right, I'm going to make my u what's inside of the denominator. Even if there's another inner function here, this is the main one. Du equals negative 2 sine 2x dx. Now, don't forget the chain rule here. Now, I don't want the negative 2, so I'm going to divide that. So I'm going to rewrite this negative 1/2, and it's going to be du over the square root of u. So we're getting to here just quicker, less work. So it's going to be negative 1/2 u to the negative 1/2 du. It's going to be negative 1/2 u to the 1/2 divided by the new exponent plus c. It's going to be negative square root of cosine 2x plus c. Same answer. So it's up to you. You can do multiple layers of chain rules. You got to use a different letter next time, the second time. Number 10, I think the clear choice is u equals the square root of x. Now, that's the same thing as x to the 1/2. So that's power rule, 1/2 x to negative 1/2 dx. Now, you might rewrite this. This is 1 over 2 square root of x dx. Now, I want the dx over square root of x. I don't want the 2. So I'm going to move that to the side. I mean, there is 6 there, but I'm just going to ignore it. I'm going to bring the 6 out front. And now there's another 2. And that's going to be sine u du. So that's going to be 12 cosine u plus c. It's going to be negative, though. So it's going to be negative 12 cosine of the square root of x plus c. All right, now the next one's kind of tricky. I can just see it coming. Usually pick the whole, what's inside something. 4 minus 2x. du equals negative 2 dx. I don't want the negative 2, so I'm going to divide by it. Now, if you rewrite it, it's negative 1/2, and then there's an x left over here still. Now, sometimes what's inside u might produce some x's that might take some of what's there away. But we can't just leave that there. So the trick here is either, the problem is we picked the wrong u, or we can't do it, or we can do it. So if we solve for x, it's going to be 2x equals 4 minus u. X equals 2 minus 1/2 u. So I'm going to plug that in there. Negative 1/2, 2 minus 1/2 u. I'm going to change the square root of u to u to the 1/2. Now, I couldn't distribute this in here before. I can't break up square roots, but I can distribute a monomial into a polynomial that doesn't have any exponent. So I'm going to rewrite it. And it's going to be 2u to the 1/2 minus 1/2 u to the 3/2. And now we can integrate. Now, you're going to have to distribute this negative 1/2 either while you're doing it or afterwards. It's up to you. So it's going to be u to the 3/2 divided by the new exponent, u to the 5/2 divided by the new exponent. You got to rewrite it back in terms of x. So here, you got to distribute this. That's going to cancel with one of those. So you're going to have negative 2/3, 4 minus 2x to the 3/2, and then plus 1/10, 4 minus 2x to the 5/2. So, a bit messy. Plus c, plus c, plus c, plus c, which should show up in your work as soon as the integrals go away. Okay, next one. Now, we could just make it this, or we can make the whole thing. I usually choose the whole denominator, the whole thing that's inside something else. And then I decide maybe if it's something else more special. But that's just usually if you try and do the weird special case first, you're bound to get confused when it doesn't work. So let's just start simple, pick the whole denominator. So the derivative of 1 is 0, derivative of e to the x is e to the 6x, and then you get multiplied by the derivative of what's inside. And then you get dx. Now that's perfect. I want e to the 6x dx. I don't want the 6 though. So I'm going to rewrite this 1/6 integral du over u. So this is 1/6 natural log the absolute value of u plus c. So this is 1/6 natural log of the absolute value of 1 plus e to the 6x. Now, final answer, I know this is always positive no matter what. So I'm not going to keep the absolute values of my final answer. I took off points if you left it unnecessarily. As a simple example, it'd be like, oh, the answer is absolute value negative 3. Well, why don't you just tell me it's 3? Or if the absolute value is 3, why don't you just drop it, right? Here, e, positive base to any power, is always going to be positive. Plus 1 is always going to be positive. This is never 0. This is never negative. We don't need the absolute values anymore. If it's always negative, then we get rid of it by applying negative to everything inside. Okay, now the next one, we could just try the whole denominator like I just recommended, but either in your head or right after you write it, you realize that's not going to work. I need x cubed. So could we try something else? Could we try the pattern where it's something squared here? So if we did that, it would have to be x to the 4th. So u equals x to the 4th. Let's try that. du equals 4x cubed dx. And that's perfect because that's x cubed dx. I don't want the 4. All right. So I'm going to get 1/4 du over 1 plus u squared. And we get 1/4, and this is inverse tangent. So 1/4 inverse tangent of x to the 4th plus c. All right, next one. Now, this one, okay, anytime you have a a polynomial or multi-term expression divided by a monomial, just distribute it first. Let's just distribute this. So this is 1 over the square root of x plus sine squared x over square root of x. Now, this I need U substitution. U equals the square root of x. I need U substitution for that. So it's going to be 1/2 x to the negative 1/2 dx. But that only applies to this term. This guy can be integrated on its own. This is just x to the negative 1/2 dx. Break it up. You could try and bring this into your whole U substitution thing when you don't need to. It's just going to make it harder, but I bet you're going to mess it up too. So it's not going to just be harder, it's going to be wrong. So in this one right here, this is 1/2 1 over the square root of x dx. That's what I want right there. Now, I don't want the 1/2, so I'm going to multiply by 2. So 2. Now, the 2 only multiplies this because this guy doesn't use any of the U stuff. That 2 comes from the U stuff. Sine of U du. So this one's already x. X to the 1/2 divided by the new exponent. This one's going to be negative cosine U plus c. 2 square root of x minus 2 cosine square root of x plus c. So sometimes some terms need it, some terms don't. Break things up, distribute things. Okay, next one. Now I'm going to just try the whole denominator or what's inside of it, at least in my head. For you guys, I'm going to write it down. So it's going to be 18x dx. Now, I don't think that's good because I don't want an x. So maybe we need to pick one of those special inverse trig ones. Something squared here, and there's a 1 here, so that's good. You got to make sure that's true first. So I'm going to go with u equals 3x, d equals 3 dx. Now I could say I don't want the 3, even though I do kind of want the 3. But there's a different way. You could just say, I'm going to move that 3 out in front, and then you're like, now I need a 1/3, and you'll notice they cancel each other out. It's going to be du over the square root of 1 minus u squared. So that's inverse sine plus c. We've got to write it back in terms of the original units, which was 3x. Now I think my answers on my solutions are wrong. Pretty sure. So we got it. All right. Next one, we could try the whole denominator, at least in your head. And clearly it's not going to work because we need x to the 4th. So you can't involve x to the 10th. But maybe something square. That'd be x to the 5th. And you're like, oh yeah, that's going to work. U equals x to the 5th. Well, then du equals 5x to the 4th dx. I want x to the 4th dx. I don't want the 5. So I'm going to rewrite this. 1/5 du over the square root of 1 minus u squared. So that's inverse sine. 1/5 inverse sine of u plus c. We write it back in terms of x. So it's going to be x to the 5th plus c. Okay, next one. Now, you might start with, u equals the square root of x, but this is going to be one of those ones that there's still going to be another layer because we cannot integrate tangent. Some of you guys are going to put like, secant squared. You're going the wrong way. So if you realize that, then maybe we should write this sine of the square root of x over cosine square root of x times 1 over square root of x dx. You could do that, but then you have to do another layer of U substitution. The quicker one would be U equals cosine square root of x, and then du equals negative sine square root of x, but then the chain rule says take derivative of what's inside, so it's going to be 1/2 x to the negative 1/2 dx. So du equals negative 1/2 sine of the square root of x over the square root of x dx. So all this stuff right there is your du. Don't want the negative 1/2, so I got to multiply both sides by -2. So it's going to be -2 du over u. So it's going to be -2 natural log of the absolute value of u plus c. Your final answer is going to be negative 2 natural log of the absolute value of cosine squared of x. Now, can I get rid of these absolute values? Is cosine squared of x always positive no matter what? Nope, it's positive sometimes and negative sometimes, so you need those absolute values in your final answer. So that's all the integration stuff, and then we got some motion stuff. So for the motion stuff, I've given you acceleration, give you initial value for velocity, initial value for position, and you need to find a bunch of things about it. What you might try and do first is just work backwards to find velocity and position just to have them ready to go. Velocity is the integral of v prime, which is the integral of acceleration, which is the integral of 3t squared minus 12t plus 9 dt. So velocity is 3t cubed over 3 minus 12t squared over 2 plus 9t plus c. When you use the initial condition for velocity, plug 0 in, it should give you 0. Those are all 0, so c is 0. So your velocity is officially t cubed minus 6t squared plus 9t. Position. Not that we necessarily need it. We could probably get away without it, but if we were to do it, it'd be st equals the integral of s prime, which is the integral of velocity, which is the integral of t cubed minus 6t squared plus 9t. So position is t to the 4th over 4 minus 6t cubed over 3 plus 9t squared over 2 plus c. The initial condition, if you plug 0 in, you get 2 out. So 0 to the 4th over 4, 2 times 0 cubed, plus 9 halves 0 squared, plus c adds up to 2. Now those are all 0, so c equals 2. So your final position equation is 1/4 t to the 4th minus 2t cubed plus 9 halves t squared plus 2. Now, I don't know if we really had to do that. So it's kind of up to you if you want to wait, but we'll just have that there. Moving backwards is when velocity is negative. So we need to line check. We need to figure out when is velocity 0 and then do a line check. So when is, we could factor a t out. And then we can factor more t minus 3, t minus 3. So t equals 0 and t equals 3. So if we did a line check, put 0 on there, 3 on there. 3 is a bounce. So test, tell me what you're testing, label your line checks. Time equals 4, far right. Positive, positive, negative. So it's moving backwards here. You could say negative infinity to 0, but we don't consider negative time on these, so the answer is just going to be none. So, but we got the work. Slowing down means acceleration and velocity have opposite signs, so we need to do another line check for velocity, like kind of try and line it up. So acceleration, we got to set it equals 0. So we could factor a 3 out, which I think would just be helpful, make things smaller. And then this is going to be t minus 1, t minus 3. So t equals 1 and 3. So I'm going to do a line check. I'm going to try and line it up with this one up here. So 1 would be over here, and 3 should line up. Test a value, no bounces this time. T equals 4, positive, negative, positive. So I'm trying to figure out where they have opposite signs. So the opposite signs here, but we're not going to keep that in our final answers because that's negative time. They have opposite signs here. So 1 to 3 is when they have opposite signs. Now at 1, so 1 to 3. You want to do 2 line checks above and below each other. Speeding up, they have the same sign, both positive, both negative. Slowing down, they have opposite signs. One positive, one negative, doesn't matter which one. Minimum velocity, maximum position. These are EVT problems. You need to show EVT work justification. So we've already done a bunch of stuff. We already found, so minimum velocity, we'd want to take the derivative of velocity and set it equal to 0. Well, the derivative is acceleration. And we already did that right up here, and we got t equals 1 and 3. So those are your critical points. These are your endpoints. So you're going to make a table, and you're going to plug in 0, 1, 3, 4. And you're going to plug them into the velocity equation. T cubed minus 6t squared plus 9t. So if I plug 0 in there, I get 0. If I plug 1 in, I get negative 5. I get 4. If I plug 3 in, it's going to be 27 minus 54 is negative 27 plus 27 is 0. If I plug 4 in, it's going to be 64 minus 96, right? Let's see, 64 minus 96 plus 36. So that's 100. So that one's going to be 4. So there's actually a tie for the max and a tie for the min. So whichever one you're looking for, you need to identify all the possible answers. So we're going to say min velocity is 0 at time t equals 0 and 3. Now, I don't think we have any units officially on this problem. It's not gravity, so we can't assume. But, and if you're a justify, you'd say by extreme value theorem, checking endpoints and critical points. Okay, maximum position, 0 to 10. Well, it's the same. Oh, max position. So we need to find S prime, which is velocity, and set it equals 0, which we did earlier. We set velocity equals 0, and we got t equals 0 and 3. These are your endpoints. These are your critical points. So we're going to make a table. 0, 3, 10. And we have to plug it into position. So we did find position earlier, so that's coming in handy. If we hadn't, we'd have to do it. So if you plug 0 in here, you get 2. If you plug 3 in here, 9 times 81 fourths minus 2 times 27 is 54 plus 81 halves plus 2. Least common denominator is going to be 4. So that's going to be 216 is negative. And then we have 81, and then 2 times 8, 162, 243, 251 positive. So that's going to be 35 fourths. Okay, if you plug 10 in, it's going to be big numbers, I guess. 100,000, 10,000 divided by 4 minus 2 times 1,000 plus 9 halves times 100 plus 2. So this is going to be 2,500 minus 2,000 plus 450 plus 2. So that's going to be 500, 950, 952. So we're looking for the max. This is the max. The min was this one. That's the min. So we could say max position is 9:52 at time t equals 10. Gotta have the work to back it up. Now I'm not giving you guys much room here. On the test, you have more room. Okay, find the difference between Johnny's average velocity and his instant velocity. Well, instant velocity is just the velocity. Average velocity, well, v average is going to be the slope, the average slope of the position curve. So 3, 0 minus, or S3 minus S0 over 3 minus 0. Slope of the secant line between the endpoints. Now, let's see, did we find, yeah, we plugged 3 in here, so we got what, 35/4 for that, and then you plug 0 in, and we got 2. So we can take advantage of that work. So that's going to be what, 27/4 over 3, which is going to be 9/4. So that's V average. Now they said difference, which kind of sounds like we need to subtract. V2, that's instantaneous velocity. We just plug in our velocity equation. It's going to be 8 minus 24 plus 18, which is going to be 2. So the difference between the average velocity, so you probably start with that, minus the instantaneous velocity. And you get 1/4. I don't know, did I make a mistake? 8, 27, 9/4. I don't know. I have a number in the answer column, but it doesn't seem. Oh, hold on. No. So it's 20. Okay, velocity. We plug 2 in. Where's the velocity equation? I think I made a mistake in my work. So I think it should be 1/4. My work, I wrote that the instantaneous velocity was 20. But I don't think that makes sense. Okay. All right. From a graph, answer some questions. What time, this is position graph. What time is Johnny at rest? So that'd be S prime equals 0, velocity equals 0. The slope of this graph is 0. So I'd say B and D. T equals B and D. Moving forward, be positive velocity, which is positive S prime. So that's when the slope of the graph is positive. So I'd say B to D and not include the endpoints. I'm not talking about increasing and decreasing. And I'd say D to E. If it said position increasing, then we'd say B to E brackets. And you wouldn't break it up because you include those. Okay. Speeding up, well, I'd probably label the graph real quick. This is negative velocity, positive velocity, positive velocity. And then the concavity of this is acceleration. So it is positive acceleration, negative acceleration, positive acceleration. So I want to know, was the speed up, where are they in agreement? They're both negative right here, and they're both positive right here. So we're going to say B to C and D to E. Now we got to figure out if we should include the endpoints or not. At this end, is the acceleration positive? Yes. Is velocity considered positive? Well, I usually include endpoints for that. So I guess put a bracket. I wouldn't worry too much about it, but that's sort of the stance I'm going to take this time. And then C, we don't include because it's the end of concavity. D, we do include as the end of velocity, but not concavity. And then just make sure. Yeah, I don't think we should include D. E, we shouldn't include its endpoint. So, okay. All right. How about the graph of velocity? Could we answer some questions? Find times when it's at rest. Well, that's velocity equals 0. That's the slope of this graph equals 0. So I'd say it's at rest, or it's when this graph is 0. These are velocity values. So I'd say at time 0. Slowing down. Well, velocity is positive the whole time, right? And then acceleration, slope of this is positive here. Positive here, it's negative here, and it's 0 here. So where are they slowing down? Where they have opposite signs? Positive, 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 negative. So I'd say 4 to 6. Let's see. No, they're both positive here. It's here. 6 to 8. Moving forward is just positive velocity, which is the whole time. 0 to 12. Accelerating positively. Positive acceleration means concave up on the original graph, but on this graph, it's a positive slope. So I'd say 0 to 4, and then I'd say 4 to 6. I think we should break it up because at that corner, acceleration isn't defined. So I think we need to break it up. Okay. All right. Okay, rocket. So this is a gravity problem. So gravity, you guys should memorize. Position is negative 1/2 gt squared plus v naught t plus s naught. Now for us, we're going to use g equals 30. Actually, it's positive 1/2 is negative 32 feet per second squared. So our position equation is going to be negative 16 t squared plus. Now here, launch vertically, this is your v naught. So that's going to be 64 t. That's your s naught. So plus 80. So there's your position equation. Velocity is really easy to get by taking derivative negative 32t plus 64. And acceleration is negative 32, which is what it should be. It should be down and 32 for gravity problems. So we just found the equation for velocity. I did a little work over there. And then the speed. Now speed equals the absolute value of velocity. So if we plug 3 in there, it's going to be negative 96 plus 64 equals negative 32. So it should be positive 32. And the units, we need units on these, feet per second. Okay, velocity impact. So we got to figure out when is impact. So impact is when position equals 0, vertical position. So we're going to take the equation and set it equal to 0 and try and solve. Now, I think I could take a 16 out of these. I'm going to take a negative 16. Minus 4, minus 5, minus 5, plus 1. So I get 5 and negative 1. That's when it's going to be impact. Now, we're not going to take the negative time because what it is it's like it starts at a height here and goes like that. But it's saying, oh, we're going to go back and hit the ground before we started. Well, that's not going to make sense. So the times 5 of impact, which we might need for some other future questions, velocity at 5, well, we just plug it into the velocity equation. We get negative 160. So we get negative 96. And the units are feet per second. It also makes sense that you get a negative answer because it should be coming down and hitting the ground at impact, right? So it should be negative. Maximal height. Well, that means we're looking for max S. So we need S prime, which is velocity, equal to 0. So T equals 2. That's your critical point. We need endpoints. Well, endpoints are going to be time 0 to time of impact, which we found was 5. So we're going to make a table. 0 to 5 time. We're going to plug them into the position equation, which is negative 16t squared plus 64t plus 80. So we plug 0 in there, you get 80, which is the initial height. That makes sense. If you plug 5 in, you should get 0. You could double check it just in case. And because if you plug it in here, it's going to be 16 times 25. That's negative 400 plus 320 plus 80 equals 0. Okay, if you plug 2 in, it's going to be negative 64 plus 128 plus 80. So that's going to be 60. That's going to be 144. So there's your max. There's your min. So we're going to say the max height is 144 feet at time t equals 2 seconds, because units are feet per second. Initial velocity of a second rocket launched upward from 32 feet, reaching the same velocity at impact. Okay. So we're trying to find the initial velocity. We know the initial height. Our equation is S equals negative 16t squared plus v naught t plus 32. It says reaching the same velocity at impact as the first rocket. Okay, well, reaching the same velocity impact. Well, I think to reach the same velocity impact, it has to be falling for the same amount of time after 0. So it's got to have the same max height. Which should happen at the derivative of position equaling 0. And so t equals positive v naught over 32. So then we have the time. So if we plug that in here and we set it to the same max height, then I guess we could find the equation. So this is harder than what I'd probably give you on the test. So v naught over 32 squared plus v naught over 32 plus 32 should equal 144. So if we do that, we get, this is going to cancel with one of these, but then there's still another. So we get a 2, and then there's another 32. So it's going to be negative 1 over 64 v naught squared plus 1 over 32 v naught squared. Now let's subtract this 32 to the other side. 112. So least common denominator would be 2. So it's going to be positive 1 over 64 v naught squared equals 112. And then we're going to multiply both sides by 64. I'm going to leave the 64 like that, though, It's going to be easier to simplify the radical. I'm going to take the square root of both sides, plus or minus. It's got to be positive. It's got to go upwards. So we're going to go with the positive, but it should be in your work. So we're going to take an 8 out, and this is 2 times 56, which is 2 times 28. So we can take another one. 4 times 7, take another one. So I get another 2, and the square root of 7. So V naught equals 32 square root of 7 feet per second. So that was kind of crazy, but whatever. I'm not going to do that. Okay, the time at which the velocity is the same as the average velocity. Velocity is the same as the average velocity. So this is the second rocket. So we got to find the average velocity and an equation for the instant velocity. So we have the instant velocity. I guess we have it now. Let's see. Now, I guess this one's supposed to be for the first one. I mean, we could do it for this one, but it's going to be gross. So let's try for so velocity equals negative 32 t plus 64. Average velocity should be the position at time of impact, which we got was 5 minus initial position. So this is for the original rocket. I mean, you try it for the other one, but it's probably going to be much worse. Okay. So what's the initial position? I think we calculated some of these up here. It was 0 for 5, which is time of impact, and 80 at time 0. And so it's going to be negative 16 feet per second. That's average velocity. It's negative, which makes sense because it's going up for a short amount of time than it's going down. So there's a lot more negative velocity, so it should be negative. So then the actual velocity equation is right here, and we're going to set them equal to each other and solve. So we're going to do V equals V average. So negative 32t plus 64 equals negative 16. So negative 32t equals negative 80. So t equals 40 over 16, 20 over 8, 10 over 4, 5 over 2 seconds is the time where the average velocity equals the instant, the actual velocity. That's it. Make sure you're ready for your retest.